Hi students, now we see differentiation of modulus functions. First question, if f of x equal to x times mod of x, find f dash of x, that is differentiate the function f of x. First of all, we know about mod of x. Mod of x has three values. If x is greater than or equal to 0, mod of x is plus x. X is 0, mod of x is equal to 0, okay? If x is less than 0, mod of x is equal to minus x. Now we draw the graph for this mod of x. So x-axis and y-axis, this line is called plus x. Okay, this is origin here. This line is called minus x. Okay. This is the graph of mod of x. Mod of x is always continuous functions, but not differentiable at x is equal to 0, because left hand derivative and right hand derivative at x is 0 is not unique, is not same. Therefore, mod of x is not differentiable at the point x is equal to 0. Okay, note that. Now, in these functions, x into mod of x, we use these the two values. Given f of x is x into mod of x, we write if x is greater than or equal to 0, mod of x become plus x, so x into x, x is square, okay? X is square. If x is less than 0, mod of x is minus x, so x into minus x equal to minus x square. Okay. Now we differentiate the functions. F dash of x is equal to differentiation of x square is 2x. If x is greater than or equal to 0, if x is less than 0, differentiating minus x square, we get minus 2x. Okay. This is the derivative of x into mod of x. If x is greater than 0, what is f dash of x? 2x. If x is less than 0, what is f dash of x? Minus 2x. Okay. That's all. Next problem. Second one. Differentiate square root of x square minus 4x plus 4. So in this function, don't differentiate directly by square root rule, because x square minus 4x plus 4 is a perfect square. Okay, we write x square minus 4x plus 4 equal to x minus 2 whole square. Root of x minus 2 whole square is mod of x minus 2. Okay, I am writing now. Take this as f of x under root of x square minus 4x plus 4. X square minus 4x plus 4 is a perfect square. Okay, so write it as x minus 2 the whole square. So we know root of x square is defined as mod of x. Okay. Don't write plus or minus mod of x, only mod of x. Similarly, under root of x minus 2 whole square is written as mod of x minus 2. Now this is f of x. If it is x minus 2, we differentiate directly 1 minus 0, 1. But x minus 2 in the modulus. Okay. So, first of all, we identify what value of x the function x minus 2 is positive and what value of x the function x minus 2 is negative. Okay. So clearly, if x is greater than 2, x minus 2 is positive. Okay, greater than 2 means we put x equal 3, 4, etc. Substitute in x minus 2, definitely it become positive value. Okay. When x is less than 2 means, for example, I am taking x is equal 1 here. Substitute x is equal 1, 1 minus 2 is negative. Okay. For all x less than 2 values, x minus 2 become negative. So, we divide mod of x minus 2 as two functions. X is greater than or equal to and x is less than 2. Okay. I am writing now. So, f of x is equal to, if x is greater than or equal to, okay, more than 2, that means I am taking it as 3, 4, etc. Substitute x equal 3, 4, etc. X minus 2 become positive. So, write it as x minus 2. If x is less than 2, for all x less than 2 values, x minus 2 is negative. So, we write it as minus of x minus 2. Okay. Because definition of mod of x is positive and 0 it become x is less than 0, mod of x become minus x. Okay. Mod of x became 3 ways. Now differentiate this f of x directly. A differentiation of x minus 2 is 1 minus 0, that is 1. If x is greater than or equal to, now differentiate this minus of x minus 2, it will become minus of 1 minus 0, that is minus 1. If x less than 2, okay, this is the derivative of under root of x square minus 4x plus 4. So, in under root, the function is perfect square, we change into modulus and then differentiate. That is very important to note. Here, don't write equal to 2 because at x is equal to, the function is not differentiable. Okay. X is equal to, in the function f of x, we write x is greater than or equal to, but in derivatives, when you differentiate at x is greater than 2, f dash of x is 1, x is less than 2, f dash of x is minus 1. What happened for x is equal to, at x is equal to, the function is not differentiable because left hand derivative and right hand derivative at x is equal to is not same. Okay. So note that. Left hand derivative means left side of 2. It means less than 2 means we take the value very close to 2 in left side. Okay. That is left hand value. For example, I am taking 2 here. This is the left neighbor. Left neighbor. Okay. This is the right neighbor. right neighbor. Okay, so in left neighbor point, right neighbor point, for x is equal to, the derivative is not same, because left neighbor of at the left neighbor of 2, f dash of x is minus 1. At the right neighbor of 2, differentiation of f of x is plus 1. They are not same. Okay, therefore at x is equal to, the derivative does not exist. That means if x approaches to, f dash is equal to minus 1 in left side. X approaches to in right side, f dash of x is equal to plus 1. Okay, so in left side, right side, derivative is not same at x is equal to, therefore at x is equal to, the derivative does not exist. Okay, that is the meaning. So note, left hand derivative of f of x at x is equal to is minus 1. Right hand derivative of f of x at x is equal to is plus 1. Okay, so they are not same, not equal. So derivative does not exist. Does not exist at x is equal to 2. Okay.